Boy,
Well, I'm glad somebody remembered to put the intro in.
We
today.
finally have an intro.
Yeah, but it's
Again.
a wrong intro. I had that world thing at the end of it, so I got to find the right video. I couldn't find the videos to upload. But anyway, we're getting better.
Oh, yeah, we're missing that little clip of it.
We are pros. And speaking of pros, Grayson, damn, you do good content. Holy shit.
Thank you.
I linked your channel in the description of this because there are some things like where the 5 Christians grill you. How in the hell were you like totally drunk on your ass while you did that? Or, I mean, were you taking tranquilizers?
No, I was painfully sober.
3 hours. Oh my goodness.
Yeah. Well, I enjoy talking about all these topics, and sometimes people ask some questions that are interesting that really get me kind of going on the explanations and the thought processes. Wow.
Yeah, I've got 1 or 2 little clips from that. I'd like to show it sometime. Then so Chris, we got the debate. So
yes.
I don't know. I don't know.
Yeah, I mean, I guess technically it was a debate. It was on Modern Day Debates, so
right.
Yeah, but it was something else. So it was TRock that I was debating. He's kind of a standing for truth acolyte, you could say.
Yeah.
Right. He's on there quite a bit. He's got like 10 or 12 debates on there. And standing for truth has kind of just turned into this. He's made it this arena for doing debate over a bunch of different things. And so, to prepare, I watched a few of his debates there. And, I knew that it was going to be not great, but there were a few things that had happened in the debate where it took me some time to even recognize what he was even saying. And by the time I recognized it, it was just so off the wall that all I could think was, wow, I don't even know how to start to address this, and ended up scoffing and laughing more than actually dealing with it, which maybe is the right response. I do kind of regret not more thoroughly just blowing it out of the water than just scoffing. But at the moment, that's all.
In some ways, it's the best response. In other ways, it's not as good of a response.
Right.
I mean, I can assure you that the rest of us were laughing along with you.
Yeah. It took me some time to be like, what? Wait, that's what you're saying? Really? Wow. Yeah. Okay.
I'm not sure if I clipped the right part about how he corrected you. How I can't believe that a professor of neuroscience would not know this.
Mm-hmm.
And
there were a few of those.
That is the thing that is really key in all of these discussions, is that they're thinking about this problem, and they think that we think about the problem in the same way that they think about the problem, right? Like they believe in 6,000 years. And when they are criticizing our theory, they somehow in their mind are still applying 6,000 years.
Right.
And coming up with things like, how did that suddenly evolve? And they can't see, and they don't seem to understand how to think.
No.
And like Cordova and how he thinks about collagen and the evolution of collagen, right? Mm-hmm. And he had a paper right in front of him on a recent video that said the evolution of collagen. And he picked one little sentence out of it, and he never actually addressed the paper at all, which give you some information about how collagen, evolved.
Mm-hmm. Sure.
It's just like
and there are a few review articles out there describing evolution of collagen, and also putting collagen in a much larger context. And this is the thing about the way Sal Cordova talks about these issues, right? They're just they have these blinders on that, it has to fit within that 6,000 year old timeline that they can't even conceive of the magnitude of the question. And so, of course, for them, it must seem absurd. But, when you actually dig into any of these papers, you can, I don't know. I mean, it's just, they have to ignore so much of the evidence in order to, and just cherry pick things that do happen to sort of, that they can pigeonhole to make to fitting that 6,000 year timeline. Yeah. But they're going to ignore everything else. And that's the thing that's just so stunning about it. And that's why I was trying to highlight the bear part. I hope that kind of came through.
Well,
quick administrative point. That link to Grayson's channel, in the description doesn't work. I put the right one in private chat.
What the hell did I do? Okay.
Well, it gives me a 404, so it probably got cut off or something.
Okay.
Well, I appreciate you checking for that. I appreciate so that people can actually get a real working link. And then just piggybacking off of what you guys were saying, especially with how TRock is going to be looking specifically at collagen, not necessarily in this debate. I've seen other debates where TRock will bring up as a point that he likes to discuss. And I think he's going to be bringing this up in my debate with him next month in February on SFT's channel. He said that he wanted to bring up this idea of soft tissues being found in dinosaur bones, which specifically, like when you get into like what the actual biochemistry of what they're looking at is, a lot of the time is just this highly cross-linked collagen that's left over, which is like, makes sense and would be stable over millions of years old. And my favorite part about that,
taking a bone out of the ground and it's suddenly soft meat that you're finding.
Yeah, and my favorite part about that is that there's a creationist, but he's an old Earth creationist who actually has a biochemistry PhD. So he actually knows what he's looking at, and he has talked about these so-called like soft tissues in dinosaurs and dinosaur fossils, and he literally says, I mean, he's a creationist, and he says this is excellent proof that the world is not 6,000 years old. None of the material that we find that should be there if it was only 6,000 years old is there, and the only material that we find that's organic in those fossils is the material that would have lasted for millions of years.
Exactly.
It literally proves the opposite of what TRock and others like to claim.
Exactly. I mean, DNA is a great example, right? Like under certain conditions, we know DNA can actually be quite stable. That's why we can get the genome of like Neanderthal fossils going back 50,000 upwards to 100,000 years back. And there's actually some more recent works, new techniques that allow for the extraction of DNA from like soils going back upwards to, I think, almost like 1 million or almost 2 million years back, as long as it's under the right conditions. Like,
by the way, today, Aaron Ra did like I don't know if it was a replay or an actual interview live of 45 minutes with Mary Schweitzer on that issue.
Yeah, I saw that.
Go check out the Aaron Ra channel and get some more information about that.
Yeah, that was a great interview.
One other thing with that, Sal Cordova has some researcher. He's a young Earth creationist, and he did a like 100-page paper on collagen in dinosaurs, right? And in that paper, he talks about how they extracted the collagen. Okay, when you extract the collagen, if I'm not mistaken, you're going to contaminate that sample, but then he sent it to a lab. And in the paper, he admitted that he lied to the lab about the age of the sample, right? The sample was, like 100 million years old. And he told them it was, like 5,000 years or something like that, or within a certain range that would make carbon-14 dating valid, right? And they came back with a value for him of something like, 10,000 years or something for the collagen, because they had been misled. And of course, their air bars are not going to work with that sample. But anyway, the other thing is that when you extract collagen, I don't know how you would extract a sizable sample of collagen and get it so that it isn't contaminated already with carbon, 14 from the atmosphere or whatever. So
you have to completely demineralize the bone sample, and then all that's going to be left is like the organic molecules that form the backbone of it, which is principally going to be collagen. So after you demineralize the bone and you've kind of destroyed a lot of the bone, but then you're going to be left with that collagen at the end.
Collagen and a few other proteins, and it's not even full proteins; it's fragments.
Yeah, fragments,
and that's it. And that's what they mean by soft tissue.
Fragments too.
Right.
Yeah, along with that, how are you going to go through that demineralization process without contaminating your sample? You know?
Well, there are ways to go about doing it, and it's not to say that it's not a real thing, because we can extract organic molecules from fossilized bone, but these are we do know that there's a breakdown of organic molecules that occurs over some length of time, and that's the thing about the fact that this is actually great evidence of an old Earth, is that the things that we're left with are the only the very few protein fragments that actually would be stable over millions of years. And that's it. You don't see any DNA. That's the thing. So DNA can last for some time, but it actually has a relatively short half-life compared to the collagen, for instance. And we're not going to get DNA from dinosaur fossils, right? That's just not going to happen. But sure, collagen will last. And so why can't we find DNA in dinosaur fossils if the Earth is only 6,000 years old? Shouldn't we be able to get DNA from 4,000-year-old dinosaur fossils, right? No, but of course not.
Exactly.
Yeah, and the coal contains all kinds of remnants from basically weird plant chemistry, like porphyrins and anthracene, and all of these ring structures they're really stable, and you can find them in coal. And this is fossil chemical evidence, and there's a lot of it. And of course, they would say, that it has to be young because everything has to break down to carbon dioxide. And that's bullshit. It does not. There are stable organic compounds. So anyway, let's say I wonder. Okay, this debate. I don't have a lot of highlights, unfortunately.
I want to add one more thing.
What's that?
One more thing. I want to add one more thing to the argument about fossilized remains. Even if it's fossilized, even if we found DNA in fossils, or even let's say if we found a living T-Rex somewhere, let's assume that it doesn't disprove evolution, nor does it prove young Earth creationism.
Just proves that T-Rex is around.
Yeah, that's right.
Missed it. Yeah,
right.
Exactly. Yeah. Okay. So I'm not sure where I'm at here. I'm in his intro, and there was just one part I wanted to highlight in his intro, so I'll go ahead and play that and see if that pops up. And we don't need to go full screen on this because there's nothing to see. Really.
Does it withstand the test of time? Absolutely not. If you don't like the evolution story today, stick around. It'll change. Methods are consistent with design and development? Absolutely not. There are two different approaches to origins versus real-time material, medical, and technology advances, and I'll talk about that later. Is it peer-reviewed? Yes, there is a peer-reviewed system. Is it perfect? Absolutely not. Does it let a lot of garbage through? Absolutely yes. And doesn't even have to be origins based in terms of how garbage makes it through the peer review system. That actually happens in the medical field, for example, is quite common. No conflicting data that renders two possible but mutually exclusive interpretations. Absolutely, yes, there is a lot of conflicting data, and we'll hopefully get to talk about that in a little bit. So why do people think that creation isn't science?
You got to pause it.
Yeah, there's quite a few things in there.
Doesn't stand the test of time because the story keeps changing. How is that an argument against evolution?
No,
that's what we're looking for.
Exactly.
Well, and change the story to more fully fit the data.
Right. Exactly. Like if it's because he's operating from a worldview that his belief structure is unchanging, right? We're not going to edit the Bible. So therefore, if people who are working on the issues around evolution, if they discover something that contradicts a certain part of the whole theory, and then they change the theory in order to adapt to it, and obviously like big changes can occur, and we're open to that. But we're learning new things about it all the time. That's just how science works, right? Especially in something as vast and complex about the history of life on Earth, or comparative morphology, or genetics. We learn new things, and now we have to adapt the theory in order to match the new things that we've learned. But the overall thrust of it hasn't changed that much. The Earth is still
right. The root of it hasn't changed.
6,000 years old. Common descent is still clearly the pattern that we see. And if anything, like the big broad strokes of it is that it has been very consistent, and it continues to be very consistent. But the details are going to change, and that's okay.
That's I just like how he used like medical publications as an example of like how like the changes over time. It's like, okay, wait, so if you're going to use like this as a line of evidence to say evolution is not true, then using medical journals and articles should prove that medical science isn't true. Like, I don't think that he's making that conclusion.
No.
So then it's like the logic it never holds up at all.
Right.
If I were to grant, the benefit of the doubt, I think what his point is, to try to intuit what his point is, he's basically saying that the standards of peer review aren't nearly as what, say, the popular, what the general public might think, that it's this ironclad armor, and that anything that makes its way through peer review is therefore unchangeable and undenounceable,
right.
and can't be contradicted.
Yeah.
Practicing scientists certainly know that that's not true. Obviously, like, literature can make its way through and be contradicted, and that's okay. Like, there's debate that happens all the time in science. I'm heavily involved in my own research that gets debated in the literature. But the other thing is that I think most scientists would acknowledge that, like, peer review is not a perfect system, because of course there's like garbage that makes its way through, and that's just the way. That's also the nature of science. There's only so many ways that we can kind of like have some check on making sure garbage doesn't make its way through, and having 2 or 3 anonymous reviewers look at a manuscript and say that this is good or not. Well, that's not a perfect system, because like those 2 people maybe missed some stuff, or they didn't have the whole story from the paper itself, and it got contradicted later. That's
by the way, I'm sorry to interrupt, but you just reminded me, or this whole topic reminded me of a video by Dr. Joel Duff, who is a Christian, but he's not really a young Earth. He's not a young Earth creationist. It's entitled "What's Wrong and Right with Peer Review." I think everybody, if you haven't seen his material, will love his approach to things. He's just very methodical. He shows you out of papers and graphs and charts the points he's trying to make. And I put it in the private chat for you, Speed, to put in the description. Sorry to interrupt. I just wanted to get that out there.
I'm gonna check that out.
Oh, you put a link in there. Okay. Let me go ahead and copy that.
I've already seen one statement on this little list there that I have a problem with.
Which one?
What do you see?
Probably many. Well, like, I don't know if he talked about this point in the discussion yet, but like, he says, according to creation, the basic plans don't change, but according to evolution, they change drastically, he says. But it's kind of the opposite, actually, because if you take like the vertebrate body plan, for example, and compare it across time, it's remained relatively conserved. Like, yeah, obviously there are differences between the different phyla, but evolution is about descent with modification of existing body plan. The ultimate bow plan, as they may call it, doesn't really change all too much over a long time.
Not much. Yes.
So are there a lot of body plans?
Getting at there.
Are there a lot of body plans where the butt and the mouth are right next to each other?
Oh yes.
I guess there's somewhere they're the same, but still, there's a lot of designs where the butt's in the back and the mouth is up front.
There's a lot of variation
with the digestive system in the middle. So how basic does he? And once again, these are questions they never answer on their own and try to avoid.
Like our body plans are like bilaterians, and we've been bilaterians for a very, very long time, and that hasn't changed.
Even the details are surprisingly fixed across taxa. I mean, as a neuroscientist, especially one who works on a wide range of different animal models, I'm struck by how similar nervous systems are across frogs to lizards to birds to mammals. It's really, really striking how similar it is.
So what he's actually criticizing is his view of what evolutionists think about biology, and not actual statements by biologists, and not defining his terms with any kind of rigorousness.
So again, if I had to intuit to give the benefit of the doubt, I think what he would be saying is that, well, there weren't whales at one point, and then there were, and creationists would say, well, they were specially created, whereas those who accept evolution as a working model, whales obviously evolved from pre-whale ancestors, and of course we have a nice fossil record that shows the transitional specimens that
It's
go
also,
but I think that's what he's trying to say. That would be a drastic change in body plan.
and it's also weird that some creationists like what they accept as the same kind or not is very wildly between different creations. Like I think Kurt Wise, maybe I'm mistaken, but I think Kurt Wise believes that whales did descend from terrestrial things like Pegasus. And Kurt Wise is like one of the famous creationists.
Oh, interesting.
Or maybe somebody else.
Sure.
Yeah.
Well, I guess that makes it sort of easier to simplify the number of kinds that I guess would have been on the Ark. I mean, I guess if you accept that there are whales, you can just say, well, they obviously they weren't on the Ark; they're marine. So
actually, the Ark encounter has Pegasus.
Really?
As a stuffed animal.
I guess that makes sense. Like you have to include it, right? Like it's on. We have these fossils, and
although I don't think Answers in Genesis believes that Pegasus is related to like the aquatic whales, but
every
it's very funny. It's very funny that they have wow, yeah.
Every baraminologist disagrees with every other baraminologist. Those are like the creationists that talk about what constitute a kind, none of them agree with each other.
Right. Well, that's because in comparison to traditional phylogenetic methods, their baraminology is highly subjective. It's typically based on morphology, not DNA evidence.
Yeah, that's where the the discussion that I had with TRock about the bears totally just illustrates that instead of there being one bear kind on the Ark, his explanation, now that I see the molecular evidence, I guess that must mean that there were 3 bear kinds. So it's obviously just completely slippery, and there's no real way of actually using the creationist model to make any genuine predictions. And no wonder they all disagree, because it's not a working model.
Right.
By the way, I want to thank Bree from Hive Science. You can see on the screen here. He is speaking up for the non-human and non-mammal life forms.
Yeah.
So
our pretty good.
Absolutely. I did my undergraduate research with honeybees, and so I have a great appreciation for the arthropod nervous system as well. It's extraordinary and incredibly complex, and quite similar across other, like all the insects, for instance. Like they have a very, very similar nervous system.
And by the way, I should have referred to Bree
outnumber us by a ridiculous number. They must be doing something right.
I got the pronouns wrong for Bree. I keep doing this. I apologize. It's she and her, I believe.
She and her, Bree. Okay.
Right.
Or is it they and them? I'm just going to be quiet.
She and her.
Okay.
I believe. Okay. The main takeaway there is this narrative and it's one of the main creationist narratives that you have to watch for, and we should have a name for it. And the narrative is we're finding more and more complexity in biology, which is kind of bullshit, because we've been finding complexity since we first got a microscope. and that creationism, like all of the new science is pointing to creationism, and they keep saying that. And then they say, and then when you challenge them on it, they'll say, well, we haven't proved functionality for 90% of the DNA, but we will, right? Just keep waiting, because it's like tipping. Sal Cordova is a big proponent of that. Everything is tipping in the direction of creationism. The more we find about complexity, and the opposite is true. The more we find about complexity in biochemical systems, the more we realize that life is a fucking mess.
Yeah.
and messy stuff is capable of basically evolving complexity, and that's how it works.
The only reason why he can even say that is because of his worldview. He's going out It's as if he's putting on rose-colored goggles and is only finding things that are rosy, and that allows him to ignore everything else that contradicts his worldview. So when it gets thrown in his face, like my discussion about marsupials and convergent evolution and how the molecular evidence doesn't support any of the conclusions that he's trying to draw, the thing he's left with at the end was just like, oh, it's a miracle. That's all I can say. That's the only way to explain why marsupials have similar DNA, sequences, instead of not being similar to their placental analogs.
Funny how the same explanation works with pretty much anything.
Right. Yeah, I also think that it should be said that like complexity is not a criteria or a hallmark of design. Like if anything, simplicity is a hallmark of design. But like creationists will often point to saying, well, this is so complex, how could it not be designed? And it's like, the reason that we know that things like pens or iPhones are designed is because we have previous evidence to support this. We can go and we can observe them being designed. But like, just because something's complex, that doesn't mean it was designed. Like snowflakes and crystals can be very complex, or like fractal geometry can come about in chaos theory. And like you can get a lot of complex things from very simple starting variables due to like complex chaotic dynamics. Like complexity by itself is not an indication of whether or not something was designed or not. We need to, like, for our criteria, we need to demonstrate evidence that these things were designed, and complexity is not part of that evidence one way or another.
Yeah. And then in the next paragraph, they will say that man has never designed life. Okay, man has designed iPhones, pens, and automobiles, and they keep using that as an example. But then they reverse it and say man has never designed life, so God must have done it. And so those two things conflict in their arguments. And they don't even realize that they're conflicting. It's like we have never gone down with little tiny fingers and created a living cell by putting molecules together in just the right way, because that isn't how the designs of men work. Okay, we have to do things with tools and fingers and hammers and things of that nature, and they keep conflicting those two things, but they contradict themselves when they do that. And that's another thing that we should have a name for.
Well, see, the thing is about organisms, superficially, you can take things like, say, the snake jaw, for instance. You can take that in isolation and look at it mechanically, because obviously if it's a mechanical thing, it's got to interact with the physical world. Certainly that's the case. But the difference between living organisms and man-made organisms is that man-made organisms are highly modular. We can take a thing out and change it and plug something in. Living organisms don't work that way. They're highly pleiotropic. A change in one structure is going to lead to substantial change that happens across in many parts, if not the entire animal. And that's the thing about, like, say, the snake skeleton and things that we know about, like the way the snake jaw works, is that that inevitably this has led to other changes that have to occur across the whole skull and in the rest of, like, the circulatory system, for instance, and other things like breathing, right? All these things have to are inevitably affected by a change that can happen in one part of the animal, right? And gene systems work the same way. A mutation in one gene inevitably leads to other genes that are not mutated, but now being changed because of the way that they interact. And so it's highly messy. That's the thing. And their notion of things being irreducibly complex, that we're going to look at a machine in isolation, say the bacterial flagellum, and that it's this perfect, beautiful machine, and that we can't take any single thing out of it. We just know that that's not true, because, like, we can look at simplified systems of even these more complex molecular structures and see that, no, there still is some function there. So anyway.
And the other thing...
Sorry, Nestle, guys.
Do you want to go first?
No, you go.
I just want to add that, like, in some ways, yes, there is a very large degree of pleiotropy, but there is also some degree of leeway in how our bodies are, like, made up. Like, for example, one good, familiar example is our muscles. Like, our muscles don't grow out of a strict developmental program. They grow based on the cues it receives from tension between the tendons. Like if for some reason, either by mutation or maybe by some surgery, your arm becomes like a few centimeters longer, then the extra tension that your muscles will be subjected to will make them grow larger just to accommodate for that change. And that's
And then that leads to
things too.
changes in the skeletal structure, and that isn't
Also,
exactly. So it's not dependent upon, say, a genetic change. It's amazing how much just the environment and development that an organism faces can actually have a huge impact on overall morphology that can be, like I said, pleiotropic across multiple systems. So
yeah, and this is actually how, if my memory serves me correctly, there is this similar how birds evolved a new muscle in their leg. Like our legs, our lower legs have like two bones. I got the names of the two bones in our lower leg. Like they were the fibula.
Yeah, the tibia and the fibula.
And the tibia and fibula. And birds basically they still have the two bones, but one of the bones is like loose, like it doesn't connect all the way down to the foot anymore.
Right.
And because of the disconnection, a new muscle just grew because of the responsive cues based on the change in tension between those two bones.
Yeah. Sure.
Yeah, what I wanted to bring up is somewhere I have two diagrams. I have a diagram of the cell the basal lamina outside of the cell, and it's a nice little diagram, and it's got little boxes and it's got colors and all that. And then on the right, there's a picture of an electron micrograph of an actual basal lamina, with the collagen and the network underneath it. And the two things, it is so obvious that we tend to think in reductionist ways about, biology. And we have these diagrams in our head, and we have these wonderful animations of, Diane and walking on microtubules, right? And that is nothing like what's really going on in life. Life is just an extremely weird and messy thing that we have a hard time getting our minds around. And we have to keep making that distinction, and that's why we can't go down and create a cell. We don't have the technology to do that, and we're not going to have that technology for a very, very long time. They have machines.
I would bring up just I don't know if everyone else is maybe familiar with this, but Craig Venter is kind of very big in the field, and he's created, I think, a form of synthetic life. Like obviously, this is not like starting from square one. I mean, you're not building it from scratch, but he is creating like an organism that has a novel genetic sequence that is not seen in nature. It was designed by his lab. And I think that there's a lot of projects going on to create synthetic life to like clean up the oceans with plastic, or to do different like environmental impact work, or like as new sources of biofuels. So there's a lot of research where we're kind of creating new forms of life.
Oh yeah, but we're starting with extant cells and stuff. I mean, we couldn't just throw a bunch of chemicals in a tube and organize a cell out of it, and that's what they want us to do, and they insist, we can't do that. Therefore, creationism. Yet they think that God did exactly that. That with God's little fingers, he went down and created all this DNA complexity and this unbelievable complexity. The two things do not make sense. So, anyway,
I put a link to a paper where it includes the example that I just gave about the evolution for new muscle in birds, and also other examples. I think it also includes the example of the milk secretory glands in mammals as well.
Okay.
Very good discussion on how new things evolve.
Yeah, I've looked into the evolution of mammary glands and a few other things, and all you got to do is start Googling this stuff, and you'll find so many examples, or so many papers on this stuff, and you start to put together an idea. And that was his last. His last thing that he said, that we're faith-based or something. That evolution is faith-based.
Right.
Yeah. And all of our knowledge is faith-based. Like I have knowledge about my room right now, and it's pretty much all faith. Okay, I don't go and measure my room every day to figure out how to walk across it, and I don't, I don't have to look at everything. I can get up and walk, across the room without even looking at the floor because I know what's down on the floor, and I have faith that the goddamn cat hasn't rolled something out in front of me, and unfortunately, that faith goes badly sometimes.
Well, I think that there's a key innuation there, or something implicit in him saying that it's faith based. With he's not really differentiating between like having faith in something based on previous evidence versus having faith regardless of evidence. And I think those are kind of two different scenarios where the word faith can both be applied, but he's very specifically implying faith without evidence, where these other things like, I can take a step without having to look down exactly where my foot lands because I have faith that the ground is not just going to suddenly change beneath my foot. And the reason I can have that faith is because every single time I've taken a step, that's never happened. And I have lots of previous evidence that would give me the confidence to take a step forward without looking like first to make sure exactly the ground doesn't change right before I put my foot down. So evidence-based faith versus faith without evidence is a key distinction here.
Right.
Yeah. The apologists on the fundamentalist and YECN, they really, I'm going to use the word rape the idea of faith, because the kind of faith that we're talking about there with the walking on solid ground, I think psychologists call that basic trust, that there's just certain consistent things that we know are going to remain fairly stable as we develop. And that's one thing. But yeah, faith is, to most theologians, to most people of faith, to the contemplatives or whatever, is much deeper. It's much more, existential, and and the YEC people, and the Christian apologists on the conservative end, they just really do everybody a disservice when they equate psychological basic trust with faith, because I can sit in a chair, whoa, big deep experience, that's not what is really meant by faith when you look at all the writings of all the theologians and master contemplatives in the past.
So Carol the atheist is blue now, and Carol, I sent you an email, and I wanted to have you on a stream and go through StreamYard a little bit, because I watched your live stream the other day where you were having difficulty bringing people in. And anyway, let's see. Okay, you want to get to the fun part with the vitamins and the polar bears?
Sure.
I think it's around here somewhere.
Yeah.
So, now, I guess this tells you why you probably shouldn't have debated him at all. Right?
I want us to get to this thing brought up by Captive Desk eventually. I think during the debate, maybe did you super chat, Grayson, or this thing about what science is accepted by YEC?
I think that this might be referring to a video on my channel where we were reviewing a Kent Hovind video where he's trying to debunk particle physics, and he's saying, what holds the atom together? And they say it's the strong force, but that doesn't make any sense, and nobody can tell me what gravity is. So really, it's Jesus holding atoms together.
Yeah.
I saw that.
Like creationists like Kent and others all the time say, no, I really love science. Evolution's not science, and the Big Bang's not science, and now he's saying gravity's not science. Particle physics
and geology's not science because of the geological column.
So they all will say, I love science, but science is what's testable and observable, and none of this stuff I disagree with is science. If it disagrees with my, evangelical worldview, then therefore it cannot be science. And it's like, what science do these people actually accept and enjoy?
And this is like an important thing to remember. Like I remember, like when the COVID thing was new and the vaccines were new. The Discovery, I think it was the Discovery Institute who was like saying like, oh yeah, vaccines are a good thing, and then most of their followers were getting very angry with them because they've like the Discovery Institute has always been saying like, oh, science is biased, science is this secret anti-religion thing, and now they are saying, oh, take vaccines, and the followers are like no, you convinced me to hate science, but now you were trying to convince you that science is okay. So it's the message doesn't get through at that point anymore.
Interesting.
Yeah.
Oh, you emailed me back. For some reason, I didn't get it. Huh. Anyway, I didn't get that, Carol. I'll go search my folders and see where it is. I miss things. Anyway, okay, let me play this a little bit about. I think I'm in the right spot. I only have the transcript to go from, but I do have the transcript for all this. But let's go ahead and see what we got here.
Disease resistance or immunities and that sort of thing. So the food source has to account for that. And what that means to me, not being a chemist either, the molecules that your body uses, the vitamins, the fiber, the protein, whatever it is that's in your food source, has to be able to be used just like I think of a mechanical interface between a nut and a bolt kind of thing. The chemicals in your food source have to be able to support your DNA and your life cycles. So how do I account for the similarities between spectacle bears and the other bears? It's the food source and the fact that they probably have quite a bit of overlap in their life cycles.
All right, TRock, you've got a problem here because giant pandas, okay, they're also very similar to the other bears.
Mhm.
You're saying they're created in
Although, can you pause for a moment?
genetically.
Yeah, it's coming up.
I have no idea what he was trying to say there. Like,
No.
it's
Okay, this is what I could gather, right?
it's-
You're saying the nut and the bolt. So your biochemistry has to support your diet, but that's the most charitable reading that I can interpret. And even then, what he's ultimately trying to say is that the genetic sequence of animals is changing and is dependent upon their diet. That's what I'm getting from what he's saying right there.
That's what he's saying. Yes, that's right.
Also, if you have a similar diet as a polar bear, your DNA will become more like that of a polar bear.
No, so he's not quite saying that. What he's saying is that if animals experience different diets, they're going to have different rates of mutation, basically, and that's because the food that you eat, there's chemicals in it. The chemicals get into your body.
The chemicals touch.
DNA is chemicals. Chemicals interact with chemicals. So obviously, the chemicals from the food must act on the chemicals that make up the DNA, and that will cause mutations. And that's the reason why there are mutations at all in the 8 different populations of bears that we have.
It's almost like a form of homeopathy that like food has a memory, like the atoms in the atoms that end up in your DNA has a memory of what food
it's not nearly that sophisticated.
No, I actually do think that TRock is saying that, like, if the 2 bears eat the same diet, their DNA will be similar, and if they eat different diets, then I really do think that that's what he's saying. Like, from what he just said, I really do think that.
Well, okay,
I think he's being too vague to even have a discussion on whether it is right or wrong. Like,
that's very true.
Listen to about another 30 seconds and we get to the vitamins.
All right,
sure.
Somebody asked me to play that.
They eat. Do you know what they eat?
Yeah, bamboo.
Right. Do any of these other bears eat bamboo?
No.
Okay. Are there other carnivores that eat bamboo?
No.
Okay. So why does the giant panda have DNA that's very, very similar to all these other bears, but then is a lot less different? It's not quite as similar as it is to, say, like the other carnivores, like foxes and coyotes and wolves.
So what vitamins does bamboo have in it?
I don't know. I mean,
okay, so
vitamins, right?
Thank you for making my point. That's what I was saying. An apple.
I'm gonna have to go to my GNC store and ask about that.
A piece of cauliflower have a lot of overlap in terms of the vitamin content and the nutrient content that's in them. So there's absolutely no surprise to me that a panda bear eats bamboo and shares a lot of DNA similarity with.
Anyway, and then
right. And what he's saying there is that food just has chemicals in it, and apples have chemicals in it, as does meat, and but it's basically just nutrients, and so therefore, whether it's bamboo or meat, it's basically the same, but it is chemicals, and those chemicals get into your body and they act on the DNA and that's why we have mutations.
Yeah,
that is what he's saying. I'm not kidding.
See, when I hear that, I'm hearing him say that depending on the unique vitamin makeup of the bamboo versus the meat, you're going to have different DNA.
No,
for the
that's
bamboo
not what he's
vitamin
saying.
DNA.
That's not what he's saying.
Meat vitamin DNA.
No,
I really think if that's what he's saying is causing the differentiation in genetics.
He's not saying that. To me, that's too sophisticated. No. What he's saying is that bamboo and meat are made of chemicals. They have the same basic nutrients, which of course that's not true. I'm sure there's some similarities, right? Bamboo, of course, has protein in it, and so does meat. And of course, like there's carbohydrates, right? There are some basic building blocks that are going to be somewhat similar. But no, what he's saying is that because they are similar, they are basically the same thing, and they are chemicals. And because they are chemicals, they act on DNA, and that is where mutations come from. That is what he's saying.
So
it doesn't matter that it's bamboo or meat.
But then you wanted to say that there was like a gotcha, right? Where he said, see, you just made my point for me.
Right.
And the gotcha was that you didn't know the exact vitamin breakdown of bamboo. So then why do you think in his mind that was a gotcha for you? Like in his argument, what do you think that bamboo having a certain kind of vitamin breakdown in composition, what do you think he was trying to say by that?
So part of it, I think, was he was just trying to point out that I said I don't know what's in bamboo, so therefore he must be trying to make some sort of grand point, and therefore it's a gotcha. I agree with Nestling that I don't think that he really even knows what he's really trying to say, and that what he is saying is just gobbledygook. It's not clear.
But the best thing I can say is this isn't even right, nor it is even wrong. Like it's neither right or wrong. You cannot even say anything about it. It's just too vague to even have a discussion on. In my opinion, at least.
The bigger, broader discussion, because Grayson, that's what I thought initially too. That okay, well, the first thing I thought is that what he was saying is that okay, if there was an original bear form, that two bears that got off the ark, and they started having babies, and then the babies went elsewhere, and some babies went north and some babies went south, and therefore they're facing different environments and eating different foods. And I thought he was so hung up on the food thing. I was like, okay, sure, right, yeah. So different foods, animals are experiencing these different foods, so therefore natural selection is going to lead to you're facing a different environment, and so for those individuals that are more well suited for that environment, those are the ones that are going to be survived, and so like there might be a mutant that makes a bear white, and then also eventually there's going to be a mutation that's going to allow them to tolerate eating more of the whale meat and seal meat that's up in the north. And right, I you could come up, I was like, okay, that's basically like what evolutionists think, but that's not what he was saying. What he was saying is that because animals eat food, the food is built with chemicals, and chemicals cause mutations. That is what he's saying. It is that stupid. And maybe I shouldn't say stupid because it's not nice.
Are we going to play the part where he talks about the muddy water?
It's the same thing. Yes. So that's what he was talking about.
I could find that.
Yeah.
Anyway, there's a part where he tells you, I can't believe that I have to explain this to you. You're a biologist, and I have to explain to you that chemicals touch the DNA. Right. Yeah. I think it's around here somewhere, but let's see.
Yeah.
See
You're describing.
By the way,
huge.
real quick, in the side chat, I have put the nutritional content of bamboo just to settle the thing, and also a link to the article that talks about the nutritional content of bamboo.
Okay. Good, we can all learn something.
Well, there you go. That's what I'm here for, guys.
I'm actually on bamboo diet right now, so you eat nothing but bamboo all day, all night. Yeah, gotta eat a lot of it. Anyway, okay, let's see what he got here. I don't know if this
spectrum of chemistry that has to directly interface with the DNA that is.
Wait, how does the chemistry interface with the DNA?
Have you ever taken medicine before? Come on.
Yes, I'm a neuroscientist. I teach it.
Okay, how do the chemicals in your medicine affect your body in real time?
Okay, if you're talking about, okay, first of all, most chemicals that you put into your body get digested and they have to be processed. And there's enormous processing that happens before it gets to,
Does it
say,
take
the germline, which is the thing that's
God.
going to be passed down from generation to generation, right?
Yep.
You know, so like just because you drink some muddy water, that doesn't mean that the chemicals in the muddy water are actually going to affect the germline, which is the one thing that goes from one individual to like your offspring.
Excuse me, can I make a real quick little point on that?
Sure. Please.
There's a reason there's a Surgeon General's warning on cigarettes and other products like that, and a reason why pregnant women are advised, do not take this, do not take that. Are they not affecting the germline?
No.
It says right on there, don't smoke this. It's going to affect your DNA. It's going to get your DNA high.
Right. So here's my question. When I take, let's say some Metamucil, does it change my DNA? Or when I take that cough medicine my mama used to give me, did that change my DNA to where if you compared my parents' DNA to my DNA, it will be like significantly different?
Yeah, he seems to actually think that medicine works by altering your DNA sequence.
Right. That's what he's saying.
Always.
Yes.
Yeah. Although I will just point out,
when you take insulin, it changes your DNA, not the expression of genes. It just changes your DNA.
He even gets into diabetes. That the reason why there's heritable diabetes is because there may have been families that ate a whole bunch of sugar, and then that caused the diabetes, and therefore, and because the sugar altered their DNA, therefore there's heritable diabetes.
Yep.
Yeah, I will just point out that in the case of cigarettes, it is actually, it's not changing your DNA sequence necessarily. It's clumping onto your DNA at a random point. So like you kind of get, during the metabolism of cigarettes smoke, the actual chemicals kind of become sticky to DNA and stick onto your DNA at random parts. That's why every time you smoke a cigarette, you have some non-0% chance of developing a cancer, just as these molecules clump onto your DNA. But to my knowledge, it's not actually, it's actually changing the genetic sequence as it is necessarily just clumping onto it. And then I have no idea what the rate of these kinds of interactions would be on the actual germ line. Like this is like lung cancer that we're talking about here.
Yes. Right. And also other places in the body. When you smoke, most of the smoke is interfacing with your lungs and your throat. That's why throat cancer and lung cancer is so prevalent and is such a high risk for people who are smokers. But of course, the risk for cancer it can be high for a lot of other organ systems in the body when you smoke, because of exactly what you're talking about, that it can alter gene expression and affect gene expression in cells that will now cause them to go a little haywire and start dividing and change. And I think some of that can be mutagenic even as well. But, it's not to say that, like, first of all, it's a silly argument because, first of all, what does it have to do with the mechanism by which the bears diverged into 8 different species? It's none of them were smoking, that's for sure.
Muddy water.
Right? So you got to talk about like the actual environment that they would have been facing. And so he was saying like just changes in temperature could cause mutations, or like whether you're hydrated or not could cause mutations, like whether you're thirsty, that could lead to mutations. It was
it's more like when the temperature changes, those with mutations that help you tolerate the heat better survive, and he's just trying to turn that around.
Yeah. So anyway, I don't know if there's any more in that video that you want to go through.
Guys, I've seen double here. I got 2 Graysons.
Yeah, you got 2 Graysons.
Yeah, that's funny. I'm trying to think if there was anything else that's really worth discussing. I guess the one thing that I would like to just say for this audience is that the point that I was making about the bears is that we have good molecular data that we can kind of timestamp when there was a last common ancestor between various species, and we can do this within kinds as well. And I'm planning on touching on this like over the next some time to further punch holes in this whole young Earth creationist viewpoint that that from the kinds we have all these different species. It doesn't make any sense from just the basic molecular dating. So at the very least, like the people who believe in evolution, the people who accept evolution as being fact and true and believe in common descent, and the creationists who believe in the evolution of within a kind, we actually agree, right? However, the molecular data doesn't support it. The rate of evolution
is very fast. Yeah, although they believe ironically, they believe the rate of evolution is very fast.
Right. Well, okay. So first of all, they believe it's all sped up, and that's another point that I didn't really emphasize too much. I mean, except that I was saying that it's hyperevolution. The problem is the molecular data does not support their conclusions over the timeline in which that you're trying to do it. And you can go through any single kind. Gutsa Gibbon had, she did the Ark Encounter, went to the Ark Encounter in 2021, I think, and she has a Google Drive list, a spreadsheet with all the different kinds, because it's hard to even get them to commit to a kind, but at the very least, like that's a list. So I was spending some time after this debate, like kind of looking through that list and realizing like, oh man, there's so many holes in just looking at the molecular data and comparing that to this, divergence of kinds. It doesn't make any sense from just the molecular data alone. If they would have to accept that there's some. First of all, I'd have to talk to someone who understands the way mutation works and understands the way DNA works. So explaining it to TRock doesn't help. But if I can talk to a creationist who understands some of that, like even Sal would be able to get this and see that, wait, okay, I guess you're right. Like the timing doesn't work, right? The molecular dating.
Even Sal would get it.
Yes, even Sal would get this.
Even Sal.
I trust that Sal could understand this. I mean, at least most of it.
For the entire world and all of the people that are susceptible to all of these supplement things that they sell, something that's really important to understand is digestion.
Mm-hmm.
And how much and what exactly gets absorbed into the bloodstream and what it looks like after the liver gets through with it, basically.
Because there's no understanding that too. But then, so the last thing I want to say about the bears and just within the bears, so we have that molecular data.
Bears. Sorry, I had to do that.
Dub bears. I'm from Chicago, so I appreciate that. So from the bears, we've got the, it's clear that there is a phylogeny, and from the molecular data, and that's very, very clear that there was like a split between pandas and the rest of the bears, and the spectacle bears. There was a split between them and the other bears. So we have timing for this. Like there's no other way around it if you accept that they are a single kind. And I went to look at that list that Gutsa Gibbon had put up, and it turns out that yes, Ursidae is the one kind. So they say that there's only one set. There was only one pair of bears on the Ark. But of course, then TRock, the way that he got out of this is to say, well, okay, I'll just accept that there's three kinds of bears. There's spectacle bears, and there was panda bears, and then the other bears. So okay, whatever.
Given that he can make up any shit he wants to.
I want to point out another thing that's been brought up specifically about the bears, because I actually I really liked your slide about and your points about the bear evolution. So actually, I sent this to Standing for Truth, SFT, and so he watched the debate and he got back to me about his thoughts about the bears and the chart specifically about the bears.
Yes,
and his explanation doesn't make any sense to me. I was gonna express what he said and see if it makes sense to any of you guys. Maybe you could steelman his argument, because quite frankly, I do not understand what he's even trying to say.
Okay, I'm curious to hear what
he said back in notice how it's all autosomal DNA that's being mapped on these charts. I would challenge Dr. Chris to try to do the same thing, but with uniparentally inherited DNA. Like, somehow it's going to make a difference if we do Y chromosomes or mitochondrial DNA. And
it's not.
In fact, we wouldn't expect. You can't use autosomal DNA because of recombination. That's the only thing that he could tell me about. Like, I tried to press him, why can't we use autosomal DNA for this analysis? And that's all he could come up with.
Okay, well, hold on. Can I share my screen? Because that is hilarious that he says that.
I actually, maybe you're going to cover that as well, but I remember there is actually a introgression of, I think, mitochondrial DNA between the brown bear and polar bear.
Yes.
So,
and in fact, that's what this paper has. So I'm going to share my screen if I can. Okay, so I got it up there. Hopefully you can see. Great. All right. So I took, this is a really great paper, Bears in a Forest of Gene Trees, Phylogenetic Inference, complicated by incomplete lineage sorting and gene flow. So what they're talking about is that things that are complicated about bear evolution is the fact that like all of these things are relatively recent, and it does seem pretty clear that there has been gene flow before like we really got the separate species in place. And so that's part of what they're talking about from some of what we can assess from nuclear DNA versus mitochondrial DNA. And so when you compare these two, some things that they can see is that there's been gene flow between brown bears and and polar bears, and we know that they can actually interbreed. So that already that kind of makes sense that there's been like this. They're not like maybe even though they're considered separate species, it's probably better to consider them to be maybe subspecies of the same species or something like that.
And a similar thing happened with with us and Neanderthals. I think like Neanderthals used to have their own mitochondrial DNA, and then later they got our mitochondrial DNA.
So when you try to make a phylogenetic tree of these 6 bears, it can be challenging because all of this is relatively recent, and there was a whole bunch of interbreeding that happened. And of course, when you think about bears have huge ranges that they can often traverse. So it's not surprising to find out that you're going to have mass migration and gene flow across populations, even though there might be like these subpopulations that are largely interbreeding with themselves. There's still going to be gene flow that occurs. Exactly the same thing that you're talking about with Neanderthals and the Denisovians and human beings. Now, but the problem is, so if we're going to talk about uniparental DNA, their data for Y chromosome, so that's uniparental DNA, follows exactly what we see from the rest of the nuclear genome.
And it was in the same
for mitochondrial.
Figure.
Of course, and it's in the same figure.
The same figure as
it's in the exact same figure. Yep. So it follows exactly, and so the timing is the exact same thing. So there's no doubt that there was, a long distant common ancestor between giant pandas and the rest of the bears, and the same goes for the spectacled bears. There's none of that is like confusing. The only thing that is somewhat complicated and confusing are these 6 other bears where, over the last million years or so, there must have been some intermixing that occurred, and the last common ancestor for all of them was like around 1.7 million years ago, based on the data from this study. So right.
Yep.
Yes, and it's in the same figure. So here it is. Saying for truth, if you're watching this, here you go. This is the paper.
And the paper is linked in both the description, and I put it in the chat just now.
Oh, great. Awesome.
Paper. Yeah. Anyway, we got to do that for any paper we display. That's a rule.
So, I appreciate it.
Okay. So I was going to go on to this 5 Christians grilling an atheist.
It was great. I enjoyed that.
Yeah, it was a pretty fun one.
There were just a few parts that I really liked. And let's see if I can find them here. I think this is one.
Compared to the human race, chickens are pretty stupid, though.
Yeah,
correct?
I agree with you now.
Okay. I'm just wondering, can you explain what variables in the environment would cause the chicken to want to further the process of evolving into eventually becoming a human?
Okay, there's so many fucking things wrong.
There was so much stupidity in that one question.
I love your reaction there with the
I think I'm going to have to reboot my computer.
Yeah, look at your face, man. It's like, what have I walked into?
Well, when he was formulating the question, I thought it was going to go one way. When he brought up chicken, I assumed he was going to ask something about the dinosaurs or something, or like or domestication or something. I was not expecting him to say chicken to human evolution.
Who was that? Who is that talking?
I think it's this guy, Proverbs guy, in just in whatever with this God TV radio Christianity, like the creationist talk show that I had called into.
Yeah, that was just so fucking precious. Like, and what is it in the environment that made the chicken decide to evolve into humans? And then he said, I thought dinosaurs, but humans? I mean, but then made the chicken evolve into, and all throughout this entire 3 hours, they kept doing that. They kept phrasing it that way, that the thing decided to evolve into something. There's a few other little clips.
It's that really dumb argument that every single, like, there aren't so many things that creationists will all agree upon that are no-go arguments, but this is definitely one of them. Like, you know, the if humans and monkeys, you know, if humans evolved from monkeys, why are there still monkeys? But this is even worse because it's like, basically, it's like if humans evolved from chickens, no one even says that. I mean, it's a nice illustration of why the argument is so bad, why the human monkey thing is so bad.
So I used to respond to the human monkey argument as saying, like, well, if dogs came from wolves, why are there still wolves? But then I started finding creationists that don't even believe that dogs came from wolves. So now I've changed my response to saying, like, no, I have to do something that everyone has to agree with. So I just say, well, if Americans came from British colonizers, why are there still British people? So, and so far, nobody's said, well, I don't believe Americans came from British people. So,
you just wait. You just
it'll happen one day.
Grayson, I have a clip from Bubble Dumb. Bubble Dum Dum.
Yeah, he's the one that doesn't agree with wolves to dogs. He thinks that Chihuahuas are one of the created kinds.
Oh yeah, I got some good clips from him. We'll get to that. But
he was also in your chat. Like if you like last time with Chris on your channel, like he was there. Yeah.
I know. I was ignoring him. I felt like after debating for 2 hours and then chatting, I was like, I didn't want to talk to this guy. And you had already said, Grayson, that you would talk to him. So I appreciate
and I
you
did talk to him after that, and it was just as bad as you could think.
I listened to it the next day, and I saw just how bad that was. Yeah. Oh, is this it?
It's right here. Yeah.
Okay.
Yeah, I guess as long as we're talking about that, we can switch over and listen to a little bit. Let's see here.
Karstein Cave Dog.
Karstein Cave Dog. Okay, let me look that one up.
The 12,500 my knowledge by
Grayson, big problem.
Big problem.
You're not giving me the name of the breed.
Karstein
this is just
Cave Dog.
Yeah. That's just the place where they found this bone.
That's not is not a place.
That's not the name.
Okay, that was where he says, okay, you were giving him the name of the breed, you know, like we have
German Shepherd. That's not a breed; it's a place. It's German. What's the breed of German?
And shepherd is an occupation.
Yeah, I had
to go look in the labor and statistics manuals for that.
So, like, his whole thing was saying, why can't anybody name for me what breed was the transition between modern Dalmatians and wolves? And then I pulled up a study where they do a genetic analysis on ancient dog specimens that they had found. And they found that their DNA was, like, ancestral to modern European species, but it wasn't, like, it was more basal than modern breeds.
Right.
So, like, that's the exact transition that he's asking for. And then he gets caught up on, well, how come they didn't give it a name?
Right.
And then I read 5 of the different specimens as they were identified in the paper, and, like, those would count as the 5 names. And then he says, but those aren't names. Like, the Karstein Cave Dog is not a name. That's just a place, the Karstein Cave. And I'm like, I mean, how do you even engage with someone like that?
They want something like the fluffy chicken hound or something.
And the thing that's so crazy about it is that I mean, most creationists accept that dogs and wolves came from a common ancestor.
Not Bubblegum.
No,
he's gonna die on that hill.
Yeah.
And what he did right there is called, I think it's called the Chewbacca defense. Like, he's making an argument that's completely irrelevant to the point, and he's like, "Oh, if you cannot answer this argument, then
right, you can't name the breed, so therefore,
you can.
Yes, so therefore, this is not an ancestor of European dogs." Okay.
Yeah, even though the genetic sequence shows it to be ancestral and shows that it is not any currently existing breed, but until they decide to give it a name, he thinks it's not real.
So who would give it the name? Would it be is it Winchester? What's the name of that kennel in England that does all the shows and stuff?
The Westminster Dog Show.
Westminster, yes. I guess they have to give them a name or something.
They would have to give it a name, yes. That would be a little bit of a weird show, because it'd be like, you know, having a fossil dog on a leash and you're just dragging it around.
It's also important to know that dog breeds are modern constructs. They didn't really exist. Even a few hundred years ago, there were no breeds established. Just it's a very quite modern thing.
Yes, exactly. That's the other thing that's so nuts about that weird argument he has. Like, we know that there have been breeds that have come about in just over a few hundred years. Like, people describe in the record having bred dogs, and that you can see over 100 years the emergence of new breeds, right? Like the English Bulldog didn't exist a few hundred years ago, and we know the process by which they came about. So it's just nuts. Like, I don't know if that same historical record exists for Dalmatians. I haven't looked into it, but you would imagine, why couldn't that also work for Dalmatians, right?
Yeah, and breeds aren't really part of the scientific naming convention anyway.
They're arbitrary.
No. Yes, it's very arbitrary.
Oh, I've brought up Canis familiaris, and I've gone through these arguments with him, but he's just so stuck. And the reason he chooses Dalmatians is because we actually have like very detailed historical pedigrees for a lot of the breeds of dogs that we have now that we can point to.
Right.
But with Dalmatians, the historical accounts are lacking compared to some other breeds. So that's why he chooses Dalmatians particularly, because he's done the research. He knows that like the historical record is a little bit shifty on it. So he latches onto that, and then he'll ignore any of the genetic evidence that we have. And he'll just say, oh, well, look at Dalmatians. They've got no idea where they came from, blah, blah, blah. So he's doing this very deliberately, and he won't be told anyway. Like, he won't be told otherwise. No new information that you present him with will cause it. Like, he won't look at it. He thinks that he's already done the research to this and that there's no answers. So anything that you bring up can't be an answer.
The fact that there's a historical pedigree for other breeds shows that breeds can come about via artificial selection. And and the
other thing, they will claim that that's adaptation, that basically it's environmental factors. And like, for instance, the shorter breed, there's a short breed dog, and we know the exact mutation that causes it. And it is a mutation. And that dog has much shorter legs. I think it's the FOXP gene or something like that.
I think it is.
Either the transcription is mutated or the gene itself is mutated. And it results in shorter limb.
The FOXP family member, the FOXP family is a family of transcription factors. I actually did some research in FOXP2 in songbirds in my postdoc. And so it affects the transcription of lots of other genes. So that's an excellent case of where, especially, when you're thinking about how does the mechanism of artificial selection lead to substantial change in an animal. Well, if you can change, if there's a mutation that arises in a transcription factor, it's going to alter the expression of hundreds or maybe even thousands of other genes in lots of different tissues. So therefore, it can have a huge effect from just a single point mutation.
Yeah, there's these things called pioneer transcription factors that basically one pioneer or first gene in development will turn on a whole stream of huge, like hundreds of downstream modifications to a body plan, basically, by this pioneer factor. That's how tissues differentiate and all of that.
Yeah, exactly.
We were just asking ChatGPT about that. Go ahead. That's like.
I'm so sorry. Like one other argument that the Bubble, I would just call him Bubble. He was talking about Haeckel's embryos in the chat, and I don't know if you brought up embryos during the debate, Chris.
No, it didn't come up. I don't.
No,
think.
It didn't.
No.
Yeah, I noticed that he was chatting about that, but I don't know where that came from either.
I have a few things to say about Haeckel's embryos, and ontogeny recapitulates phylogeny. Like back in 1810 or something, they had that idea that ontogeny recapitulates phylogeny. And then for the next 100 years, they found all kinds of reasons why it wasn't true. Right. And they pointed to the pharyngeal arches, right? But there's a hell of a lot of truth in what Haeckel did, because we do have pharyngeal arches, and they are developed with the exact same genes that gills in fish develop. And they have pharyngeal arches, except that in gills, they actually they have a downstream. The slit forms for one thing. There's some cell death, apoptosis, and the slits form, and part of that pharyngeal arch becomes the jaw of the fish. Well, in humans, the same part becomes the jaw of humans, and other parts that were the gills in fish become our ear parts and our ear bones. And so, but we do have pharyngeal arches, and the genetic pathway to that goes way back before fish.
Right.
I mean, they found them in very primitive branches off of fish, or what they consider primitive branches off of fish.
Well, sorry. Go ahead.
No, there you go.
I was going to say what they want to do is they want to point to, back to the 19th century and Haeckel's initial drawings,
Right.
And they want to say, okay, well, if that's been proven wrong, then all of Evo Devo has to be false. And there's an entire very substantiated field of Evo Devo, where there's a lot of really cool research going in, and they just want to lump Haeckel's drawings in to somehow debunk that entire field of research.
Right. Yep.
It's a really weird argument. They want to claim that it's because Haeckel supposedly faked his drawings. There is no similarity between the embryos of us and fish, for example. But no, that's not true. We can see.
Now, did he fake his drawings or just adjust them to clarity?
That's also a thing. There was a dispute between Haeckel and one of his rivals, and his rival accused him of faking his drawings, but that was never substantiated. And it's true that Haeckel's drawings were simplified for the purpose of illustration. For example, if you look in your textbook and you look up the anatomy of a heart or a liver, it's often not anatomically or accurate to every single detail. It's just simplified for the illustration of explanation, and that's basically what the Haeckel did to some degree. It's not fraud for what he did, at least.
Glad you caught that one, Scott.
It's my opinion. But even if Haeckel was fraudulent, it's irrelevant to the evidence that it's
absolutely
that we know of today.
Right.
Yeah.
Something that was 200 years ago.
200 years ago, for God's sake.
Right.
Give us a break.
So much has happened since then.
Yeah. But in the last 10 years, that whole pharyngeal arch thing has come up again, and they found all kinds of homology.
You see, that's the problem with this evolution thing, is it just keeps changing. It's a different story every decade.
Yeah, we keep finding out that God did it. Or did he? Okay. So I got, let's see, a little more on this Christian thing. So it's very interesting that Brett Keene's philosophy is that all logic and rationality in the universe requires a rational mind. And they all think that way on that panel. And that's why they kept coming back to, how does something decide to evolve, right? Because this rational mind is so thick in their heads that nothing can happen without rationality, that there has to be a rational mind. But I'm not sure what I have highlighted here.
Fitness.
Yeah, but that's where the question lies. Where did it come up with the concept that it even needed this or required this in order to be able to go through the survival process you speak of? See, you keep on speaking of the horse, but not the carriage. I'm asking.
Can we pause this real quick?
Looks like we got
I just want to say, because I'm a little older, a little harsher. That's just the stupidest question I've ever heard in terms of evolution.
Well, you
have mutations. These mutations help, cause certain conditions within the population. Things change in the environment, and things die, and what's left are fit. They don't have to decide to be fit. It's not like a herd of elephants decided to go to Gold's Gym and get really fit so that they could survive and create mutations or whatever. It's that whole line of reasoning is just stupid.
Yeah, I have to disagree with you completely. If you go through and watch the rest of that video, there are countless questions that are way more dumb than that one there. That was probably in the top 10% smartest questions asked during that entire video. I would have to say that even the other question that we listened to with the chicken evolving into humans, I would say that's a dumber question.
Okay, yeah, you're right. You're right. But you see, when you're old and grumpy, every stupid question is the stupidest question you ever heard. So, but anyway, yeah. I can see where what you're saying is very true, Grayson.
Yeah. So let's see. I'm not sure if there's any more.
Adam
there.
Lauren, welcome to the room, Grayson.
Yeah. Okay. So let's see. We'll go ahead to 3. You see, I skipped a whole bunch. I'm going to have to go through this and highlight and bookmark every stupid question. Okay. And we'll do another show on it. So.
But you do agree that logic and rationality simply can't exist or work unless a mind is involved with it.
There it is again. You know, basically, logic
That's
and
a leading question, Your Honor,
are from the mind and only from the mind. And what he's confusing is the description of logic and rationality and the actual mind exercising logic and rationality. And they
basically saying, like, how can you have a place without a map? Like, how can you have a place without a map?
Yeah, it's a reification fallacy.
How can you have two minds? How can you have
does the idea of causality require an intelligence? Because when I see natural selection, to me, it's just causality. I have an unsuited regulatory system that does not allow me or adjust for me to survive at an average temperature of 88 degrees throughout the year or whatever, especially when I'm active. So I die. But Dr. Thomson, he may have a more suited regulatory system because of his genetics that allows him to survive longer and pass on his genes to somebody else. So he doesn't die before reproducing, and therefore he lives. That's a causality thing. It's not a logic, other than my statements about this being logical or not.
Right.
Evolution doesn't. I hesitate to say this because all those young Earth creationists listening to me may put me out of context, but there's not a logical system involved. It's just a causal chain.
It's a causal chain. Okay, so there is some logic to
it. Yeah.
Obviously.
If you describe it, you have to use logic.
Yes, but you're right, absolutely right. It's just a causal chain that it just necessitates. It's a necessary causal chain. There's variation exists in a population. Not every variant is going to be well suited to an environment, especially if the environment changes, right? Some individuals are going to perish and some are going to survive. Some of those variants a lot of that variation could be the result of heritable characteristics. So for those that are well suited for the change in the environment, if they survive and reproduce, then the population is going to necessarily change the next generation. And you do that enough times, like the whole population is going to change. It's just, and that's part of the reason why, going back to my debate, like TRock was like, yeah, well, most creationists believe in natural selection. I'm like, yeah, okay, I guess we don't have to argue about that because I think that's true. Because there's no other way it could, it's a causal chain of events that makes.
Remember, I don't know what this is an argument for or against, but I'm just amazed at how, like in the 80s, natural selection really was, for most of the people that I talked to, and right. I was a fundamentalist back then, they didn't believe in natural selection or any kind of evolution. Yes. Because Satan put the bones there, for the dinosaurs.
Because they don't understand it. And if you can explain it in a simple, easy to understand way, how do you even argue against it? So the thing is, like, at least most creationists who actually care about this stuff, well, they know at least that. Like, and if you've come across a creationist who doesn't believe in natural selection, already you've got a problem. Now, what they will say is like, well, they can't. That can't explain, say, the origin of more complex structures or that kind of thing, because then they get into arguments of irreducible complexity and specified information, the way Dunsky has focused on those things. But and so you kind of have to deal with that in a different way. But the other thing that's so annoying, and if we go, this is kind of going all the way back to the beginning of our stream here, is that the list of things that TRock was talking about, that he is trying to point differences between creationism and evolution. One of those things is that he says evolution is random and natural selection is necessarily non-random. That is the thing that they don't understand and is so frustrating. It's the whole reason why natural selection works the ways that it works is because it is non-random.
Yeah, I've come up with this time and time again. All this saying, oh, so you think this is all just random chance and it's unguided? And I was like, no, natural selection is a guided natural process. Like, it's not a random process.
It's a non-random process.
And it doesn't have a particular direction.
And to your point about all the creationists that actually like kind of do this more professionally and have an interest in not being made to look stupid in public. Those are the creationists that don't disagree with natural selection. Like the CMI, the Answers in Genesis, all the big wig creationists say, oh, even Ken Hovind, oh yeah, natural selection, that's totally a thing, because they know it's very easy to prove. And if you disagree with that, you can be made to look stupid publicly very quickly.
Exactly.
And the main thing that I then hear, they will differentiate. They'll say, oh, well, natural selection happens in microevolution, where you'll have varieties within a kind. But they change the definition. They say macroevolution is not speciation, like most all biologists would agree, and like any evolution above the level of species. Not to the creationists. They want to say any evolution above the level of kinds. So they say, oh, show me one kind turning into a different kind of kind. And that's the only evidence that I'm going to accept for evolution. Everything else is just microevolution. And then they'll just shut their ears.
Right. Yep.
The most powerful part of natural selection is purifying selection. That is the filter that cuts out all, like probably 80 or 90% of the mutations, because you will not have a viable embryo at all.
Well, I think most mutations are mostly neutral, so you do be careful about that.
Right. Yeah. Most are neutral, and obviously if there's a good percent that are deleterious, and this gets into the issue over genetic entropy that various creationists bring up too.
Mutations that modify the body plan or modify the expression of proteins or the biochemical makeup, those 90% of those would be probably deleterious, and they're cut out by purifying selection.
Yes,
and it's that 10% that you have left, and all of those neutral changes that you have left, that end up forming the complex interplay of networks that results in a change of body plan or biochemistry.
Yep.
And that's really an important thing to keep in mind.
I see it on a regular basis. So I work with African clawed frogs. We put a male frog and a female frog together, and we get thousands of embryos to work with, like the next day. And I will see mutant embryos, and they don't survive. Like they just don't. Yeah. The majority of them seem fine, but there's always a few mutants, and they die.
Yeah,
and they don't turn into a ninja-powered superhero team.
We don't get any of the teenage mutant ninja frogs.
I think I read somewhere that 50.
That's the French version of the show.
50 or 60% of human fertilizations, nobody even knows that they happen.
Right,
because they die.
The miscarriage happens before they even know it. Yeah.
So and God is the biggest abortion clinic of
That's right.
Oftentimes, I will run up against creationists who have to vehemently disagree that the majority of mutations are neutral, and they have to stick to this, saying, "No, there are no neutral mutations.
Yeah,
all mutations are deleterious." And I hear this line so often that every mutation is deleterious. It's just a matter of to what degree. And I'm like they literally flat out will reject the neutral model of mutations.
Yeah, right. Like rust on a car. SFT's favorite rust on a car analogy. The car rusts a little bit and then a little bit more, and we have genetic entropy. That's great.
Well, we know the scientific process behind rust, just like we know the scientific process of mutations and their results. So, that's just an easy meme for young Earth creationists to pass on. There's a couple words used in debates like this that I'd like to see people move away from. One of them is the whole idea of evolution is true. I really don't like to use the phrase evolution is true. I really like to just say evolution is supported by the data.
Right. Yeah.
That to me says more and gets us out of an almost philosophical theological conundrum, of what is it when you use the same word with two different meanings to suit your argument. Equivocation, I think.
Equivocation, yeah.
And true, yeah, you can sort of get by with the idea of evolution is true, but evolution is supported by the data kind of puts burden on the creationists, if they're brave enough, to actually show their data and look at the quality of the data, look at how you know when individual facts support a model. And that's what evolution studies is about, is supporting a particular model, describing reality.
This is why I study molecular evolution, because I don't believe in it. Okay, if you have some particular protein, right? And my first question is, how the hell did that evolve? Okay, and at the beginning, I don't have a belief. And then I read about it, and then I form a belief based on the pathway and the evidence, right? But I mean, I just don't like take it on faith. If I took it on faith, then I would never crack open a book on molecular biology or evolution.
Yeah.
Okay. The reason I study it is because I don't know how it happened, and I want to find out how it happened. And I'm not going to have any particular belief about it until I find out it did. I mean, because I'm a naturalist and a hard atheist, I kind of have to accept that, yeah, it did happen. But I mean, as far as believing it is true, that's not what I do. I study it instead. Okay. There's a difference. There's a real subtle difference. I don't have to have a rigid belief going into it.
Nope.
Okay.
Exactly.
Hey, there's a question I wanted to ask Dr. Thomson real quick.
Uh-oh.
In neuroscience lately, what is something that has impressed you or amazed you that you just want to share with students and lay people?
Let's see. There's all kinds of interesting results come about, but let's see. I would say one thing that people may not know about or appreciate that what we can use as a tool in neuroscience is the use of optogenetics. It's kind of revolutionized the way like we can design neuroscience experiments. So optogenetics are channels that are sensitive to light. And so these are channels that were found, I think, in blue-green algae or something like that. But they are channels that can alter now the electrophysiological properties of neurons. So we can alter the DNA of neurons and have them express these channels, and then we can make a small, tiny little hole in the brain and put a fiber optic cable down into the brain, into the area where, say, even just a subset of neurons are expressing this channel, and you can cause those neurons to fire by shining light in there and then turning the light off, and then they no longer fire. And you can actually, because it's light, you can control the rate at which the neurons are firing. So you just do flashes of light on the order of milliseconds or tens of milliseconds, and you can control the rate at which neurons are firing. This allows you to have substantial control over like actual behavior. So one cool experiment that I like to talk about in one of my classes is using this technique in a part of the amygdala. Now, do you guys know what the amygdala is kind of most famously known for? Like what kind of emotion it's involved with?
Yeah, fear, anxiety.
Fear, right? Yeah. So generally fear. So, and when we do this in mice, one way we can assess fear is put them in certain kinds of arenas. And one test of this is called the elevated plus maze. So an elevated plus maze will be up, and it's an X like this. And one part of the X, so like this part, will be hold on a second. Will be closed off, and then the other part will be open. And rodents don't like to be out in open space, especially since it's elevated. It's off the ground by about like 2 or 3 feet. So they will hide. They will generally hide in the in the closed part, and they'll spend some time in the open part, but not a whole lot of time. And for mice that are like generally going to be somewhat anxious, like you can change activity in the amygdala and control the degree to which they spend out in the open arms versus the closed arms. And so you can change, like you turn on the light and like neurons are firing in the amygdala, and you can change it on the order of seconds, which is the crazy thing. But basically like over minutes, you can watch the mouse, like it's generally mostly anxious, and then you change the activity in the amygdala. And then now like, okay, so you turn on the light and then it's mostly anxious. And then if you turn off the light, then it's less anxious. And so you can control how much time it's actually spending in the open arm by just turning on and off the light. So that technique alone is something that like the general public might not be as familiar with, but it's almost science fiction-y that you can just flip a switch and change the behavior of an animal on the order of seconds or minutes. And it's pretty cool. It's a
somehow
really
that reminds me of an element of the movie Clockwork Orange.
Yeah.
Hey guys, we got a problem here. Bubblegum is in. He's showing up in my chat on Restream, but he's not showing up in the chat on. Like, has somebody banned him or?
No, it's probably on Dr. Thompson's channel. Aren't you kind of simulcasting?
Oh yeah, he is.
Oh, okay, your pair.
Yes.
Okay.
When I had signed up for Restream, and I hadn't looked. Yes, but he's apparently in mine. So I don't know if you're watching this Bubblegum Gun, but
yes,
you can go over to Speed's channel. When I did Restream, I didn't realize like I was also streaming at the same time, and then I didn't turn it off before I got on. So
I think it's fine.
Yeah,
I was confused.
It's simulcast.
Is that Pudding Brain? Oh, so he's insulting me.
Pudding
That's
Brain.
cool.
Yeah, this is Pudding Brain. So
yes.
Bubble Dumb Gun.
Well, if Bubblegum Gun, if you got here, you were talked about a little bit. So if you can go back and look at it. Yeah. All right.
Anyway.
Yep.
Okay, let's see. I got two more clips from this 3-hour stream that I just wanted to go through, and one of them I don't know why I clipped it, and the other one I do know why. So this one I don't know why.
Back pig cells from death. So they have reanimated dead cells to come back to life. So they've done that before, but I was not in that lab to directly observe it.
Well, I wouldn't have a problem with believing that that's possible. But what I find interesting about it is you would have to agree that it required a logical, rational mind to even make an experiment like that work, correct?
Intelligence.
Okay, yeah.
You couldn't just open up a lab, sit some crap in there, and all of a sudden it starts turning into something that can make love ballets, right?
Sure.
Okay.
That was the part.
I just want to reiterate my outraged. That's the stupidest thing I ever heard.
Yeah.
It's stupidity all the way down, isn't it?
Yeah,
this whole
every
stream
question
is filled with it. Anyway, that included the last part was the part that I did want to clip. That basically you can't just open up a lab and expect the thing to start writing ballads, and I don't know. I think that's
for anyone curious. This was an experiment I think back in August where they took some pig cells that had been dead for several hours and they reanimated them and brought them back to life. So that was just in 2022. I forget what question it was that. I think that he said, have we ever seen scientists bring anything back to life? No, then what do we know? And then I said, well, actually,
What about like people who die and you hit them with the electroshock pads and they come back to life? Does that not count? I bet it doesn't count to them.
I think it would have to do with the cells actually being dead.
Oh. Never mind. I was being obtuse there, I guess.
Anyway, let's see. I think that about covers everything, guys. I don't know.
I can see how just calling everything out. I can see how calling everything out there the stupidest thing I ever heard could be a discussion damper. Maybe I need to practice not doing that as much.
I don't know. It's hard. It's a target-rich environment. So
I'm thinking about doing it more lately. Because I'm just so tired of their crap, bad arguments.
Did you notice? Like Andrew coming in the comments had asked a question for Dr. Thomson. I don't know if we had time for that or
I missed.
Yeah,
well, if there's a question out there that needs to be answered, let's try to cover them. I can see Dr. Thomson trying to fall asleep though. I think
I'm all right. I'm still going.
Oh my God!
I mean, it's a big question.
Describe the nervous system is thought to have evolved using different phyla as an analogy. Okay, that is a tough question. So I mean, there are. I can briefly talk about it. Oh man, all right. So generally speaking, nervous system cells, they have chemicals that they release that end up talking to other cells, neighboring cells, and we call that's happening at a synapse. And what we think the way the nervous system came about is that it must have come from some sort of proto-endocrine-like system. The endocrine system is already set up to shed molecules and travel across space and then talk to receptors on receiving cells to initiate change in the cell that's receiving that. And so our thought process about the way neurons must have come about is that in some sort of multicellular organism, there would have been, and this would have been prior to, the split between invertebrates and vertebrates, because we do know that like the proteins that make up neurons in invertebrates and vertebrates are largely the same. So we're talking about like long time ago.
Yeah.
That it would be hijacking the material that was used for some sort of endocrine type influence of one cell releasing a factor that can influence another cell. But then eventually, like, instead of having that long gap where like chemicals have to diffuse through the animal, why not just have a process that's now connected to that other cell and have it release the chemicals there, right? Yeah. And so that's generally.
I think I just found a paper on that. So
yeah. Oh, there's tons of papers on like theorizing around those kinds of events that would have happened a long time ago. And so it's a super fascinating question though.
And there's one thing that I would just want to point out, because they were asking about like specific phyla, and I would just say like sponges are an interesting example to look at this, because sponges don't have any nerve cells,
right?
But sponges do actually have a lot of the proteins that are used in synapses. Mm-hmm. And their function is a little bit unclear right now in sponges, to my knowledge, but we do know that sponges are making these kind of like postsynaptic protein complexes, and they're serving some function for the sponges, but that function is not as a functioning synapse in a nerve cell. So some of these could have, like, chemical systems could have been co-opted. And then also, I think this is also observed in sponges, is that not only are they kind of communicating between cells with like chemical mediums, but we've also seen kind of like the kind of similar thing as an action potential. You know how a neuron will
it'll be a change in the membrane potential that will cause.
So it's like how electricity is traveling through the nerve cells. We see sponges actually utilizing a lot of the same mechanisms of action potentials, but again, they don't have nerve cells. They're not communicating that kind of information. Like sometimes, like when the entire organism needs to move really quickly, and the action potential can transmit information like 80 times faster than just like chemical hormones can. Right. So this is, we've seen a lot of like the precursor stuff to a nerve, like the action potentials and the synaptic complexes. And we see those things in sponges like before the development of any nerve cells.
Right.
Yeah, I just found some papers on that too recently, and I'm trying to figure out where they are. I can't remember how many days ago it was, but it was on basically very early development of action potentials. And I thought it was sponges. But then the other thing, the same story with light receptors. There were very simple light receptors that worked in an endocrine fashion, and then eventually got hooked up to nerves.
Well, yeah, you can have light receptors in single cells. I mean, they're just like little patches that actually even have lenses and can function very much like an eye, but it's like it's not a group of cells that's doing this. It's within a single cell. It's just an organelle that is functioning like an eye.
Exactly.
Yep.
Yeah. And as soon as you get multicellular life, inevitably you're going to have some cells wanting to influence the activity of other cells. And so you can imagine, because otherwise it's just a colonial organism. If it's going to work in some sort of specialized fashion, inevitably then some cells are going to influence how other cells are working. There's going to be diffusible chemicals. It's almost inevitable that you could have the origination of something that looks like a nervous system.
Yeah.
And using that system of like cellular life. So,
Dr. Thomson, I have another quick question about kind of how you do your work.
Uh-huh.
Do you look at the behavior of animals based on their neurology or?
Sure. So I have, I've worked with a variety of different species. When I used to do my work in songbirds, obviously we looked at the behavior because I was interested in studying the circuits that control singing behavior in songbirds. So we, in one experiment that I was sort of involved with, it was mostly run by another set of scientists that was in the same lab that I was working with. They used a virus to modify the expression of FOXP2, which is one of these FOXP family members that we talked about before. And it's this gene had originally been identified as being involved in language processing in humans, because there's a family in Scotland that has a mutation in this gene, and they have speech and language deficits. And it turns out FOXP2 is heavily expressed in a part of the brain called the basal ganglia. That's true in humans as well as in songbirds. And one thing that obviously humans and songbirds also do is that they learn their vocalization. So we were interested to see, can FOXP2 actually also influence singing behavior in songbirds? So by injecting this virus that modified the expression of FOXP2, then we could show that, yes, indeed, it's involved in singing behavior. And we had to obviously monitor the way the birds learn their song. So we would monitor, did the bird, was this bird able to copy its father's song the way the control birds did that were injected with, a virus that didn't change the expression of FOXP2. And sure enough, like, their song was completely messed up. It was like 60% similarity versus like 95% similarity.
Wow.
So yeah. So we definitely study like the behavior part. In my lab currently, we're not doing a whole lot of behavior stuff.
Have you done any work on domestic cats?
With domestic cats?
Domestic cats and vocalization.
He's going to offer to mail you a cat.
Yeah.
Do they learn their vocalizations?
They have very complex vocalizations.
That's true.
They react to me.
Yes.
And I've heard that they don't do that with each other very much. It's mostly with humans that they do it.
Yeah.
So domestic cats may have some differences in the way they're wired than, lions and tigers.
That wouldn't surprise me. I mean, the same goes for dogs with the way that they vocalize, but they don't learn the vocalizations, right?
Yeah.
But of course they can learn the vocalizations of human beings. That's the cool part, right? So there's, they learn commands, and cats obviously learn sounds in their environment, but that's different than vocal production and vocal learning.
Well, one reason why I asked is because I saw a video the other day, basically about how the cuttlefish passed kind of a fish version of the marshmallow test. The one where they give a child a marshmallow and say, if you wait 15 minutes, you can have 2, and then some can wait longer and others can't. But like this one, they involved, like, in one tube was frozen shrimp, frozen dead shrimp, and then the other one was a freshly killed shrimp that wasn't frozen, and but they had to wait for the fresh shrimp, the least, the more pleasant shrimp, and of course they waited, and I thought that's
so cool. It's not actually all that surprising. I think really the marshmallow test, especially if it's kind of simplified down to its most fundamental aspects, it requires planning and some learning, some aspect of knowing about time and also learning. And I think that, more complex animals like the cuttlefish or an octopus, I'm not surprised to hear that they can do that, because they can do some pretty extraordinary things. And their relative sort of nervous system to body ratio is actually quite large, which can be sort of a useful metric and kind of and getting an assessment of like what are the cognitive abilities of some animals versus others. It's not always perfect, but that it can be a helpful thing. Like the bigger brain you are relative to your body ratio, the more likely you are to do more complex things. And cuttlefish and octopi are relatively high on that scale.
You see, this is why I really enjoy YouTube and the internet, is you can actually ask a neuroscientist these things. Whereas before I'd be going, that's cool, but I don't know who to talk to about it.
Andrew has a follow-up question here, and I believe the answer is no, they're not independent, but depending on how far back you go, arthropods.
Yeah. No, I mean, I'm quite sure that they are not independent origins. There's far too much that's similar between invertebrate nervous system proteins and the way that they're even structured, and vertebrate nervous system proteins. So, and that's true for mollusks, arthropods, annelids, and vertebrates. There's a lot that's actually very similar in the basic structure. So this would mean that there was, prior to the split that led to all the different phyla, that last common ancestor minus the sponges would have had a nervous system. So
yeah, and all you have to do is listen to Bubblegum Dumb for a while, and you'll realize how close we are to, or at least we're going the other way.
Right.
He's one of my favorites.
Yeah.
He's one of my favorite guys to pick on.
Well, he's interesting because he's not like a Christian creationist. He's a polytheist, self-described.
Yeah.
Oh, that's interesting. Wow.
Yeah, it gets into some weird places where he thinks each of the individual races of people was specially created by different god or pantheons of gods. It's very interesting, at least.
No wonder he's so interested in the different breeds. Okay, that makes sense.
Yep.
Wow.
Well,
all right.
It's getting a little bit late for me, guys.
Same.
Yeah, we're going to shoot it in the head right now anyway, and you guys can hang around for a few minutes backstage.
Sure.
Well, if I could, I just want to say that I hit 200 subscribers actually during this stream. So
Yeah,
I'm pretty happy and excited about that. So thank you, everyone listening that subscribed. So I'm going to be doing more. Like, I have a pretty new channel. I haven't even been doing this for a month yet. So I'm going to be doing a lot more debates, more live streams, and then I'm doing my own kind of just talking about topics in science and history that interest me. So I already did one on the evolution of God, and the next one I have is going to be about the evolution of rainforests. So
very cool.
And I want to just echo that. Like, I think everyone should subscribe to Grayson's channel. It's really great. I listened to your Evolution of God thing last night when I was preparing dinner, and I thought it was really informative. I learned a lot about that. Yeah.
I want to take credit for putting you up above 200 because I subscribed during this stream.
Nice.
So I'm just going to take all
when
the
you did
credit.
it.
I just found you recently and started watching your stuff, and you're going to go. You are going to get big very quickly.
Hey, thanks, guys. Well, I'm having a lot of fun right now, and I find these kinds of topics and these kinds of discussions really, really fun and informative.
Yeah.
Yeah. Hopefully you'll come back. So
yeah.
Great
Thank you very
addition to
much
the
for
group.
having me.
Yeah.
Yep.
It was great to meet you, Grayson.
Thank you.
And we definitely want you to come on more.
And I don't think I have my outro yet, so we're going to shoot it in the head, and we're going to disappear very rapidly. So anyway, so goodbye, cruel world. We're going to end the stream.